Okay, so welcome to the final video of 7.4, and this is properties of the dot product. So properties of the dot product. Okay, so given vectors u, v, and w. So given u, v, and w. And let's have k be a real number. We have the following. So number one, u dot v is the same as v dot u. Number two, we have that u dot u is the magnitude of u squared. Number three, we have that w dot u plus v is w dot u plus w dot v. Number four, we have that a constant k times u dot v can either be k times vector u dot v, or it can be u dot k times vector v. I only distribute to one of the vectors in that case. Number five, the zero vector dot the unit vector is the same as the vector u dot zero vector, which is the scalar 0. And we'll prove that in a moment. So let's go ahead and prove a couple of these. So proof. So let's do number 2. So let's let u be given component-wise as x comma y. So that implies that u dot u will be x comma y dot x comma y, which is x squared plus y squared. And do you agree that that's the square of the square root of x squared plus y squared? So that is, it's the magnitude of u squared. Check mark there. Actually, let me do a little box. It'll look nicer. Okay. So now let's prove number 5. I like number 5. Okay, so the zero vector dot the unit vector. Well, that's going to be 0, 0 dot x comma y. So what is that? That's going to be 0x plus 0y. So do you agree that that's the same as 0y plus 0x, which is the same as, let me do it this way, y times 0? Yeah, no. I don't know why I did that. Let me just do it this way. I should have done it this way. Let me just write this as x times 0 plus y times 0. So I can rewrite this now as x comma y dot 0 comma 0, which is u dot the 0 vector. So that's for the first part. So I've proven this first of the two equations. Now I want to prove the second part. So let's go on to darker purple. So now I want to prove that u dot the 0 vector is a 0 scalar. Well, if I go on from here, do you agree that 0 times anything is 0? So it is 0 as a real number, so check mark. So they're kind of simple, but very profound. Okay, so let's recall. Recall. We had the cosine of the angle theta. Let me color code it so you remember. Cosine of the angle theta was the dot product, right? Between vectors u, unit vectors in the direction of u, and the unit vector in the direction of v, right? I think I need more room. Let me move this down a bit. Okay, so if I were to cross multiply here, if I were to multiply by the magnitude of u times the magnitude of v, I would get that u dot v the numerator on the right hand side, can be said equal to, let me use pink for this equation, the magnitude of u times the magnitude of v times cosine of the angle theta between them. Okay. This is just another way of looking at the dot product. So let's now consider the projection. Remember, the projection was the vector and the component was the scalar. So let's consider the projection of vector u onto vector v. So remember, that first included the component, which was the magnitude of u times cosine of the angle between them. That was the scalar, but then we needed to multiply it by a vector to give it direction, and we chose the unit vector in the direction of v. Okay. So I'm going to go ahead and put the scalars in front. So I'm going to have the magnitude of u divided by the magnitude of v. This is just a real number. It's just two numbers, one divided by the other. I have cosine of the angle theta, and then I have times vector v. But I'm going to multiply this by a 1, a very specific one. A 1 that gets me to the magnitude of u times the magnitude of v times cosine of theta in the numerator. So what I'm missing in the numerator here is the magnitude of v. So my very specific 1. So let me just copy and paste all of this. Copy, paste. But what I'm going to do now is I'm going to multiply. What happened? The 1 I'm going to choose is going to be the magnitude of vector v divided by the magnitude of vector v. I can do that. It's just a number. So now what I have in the numerator, if I rearrange things, I have the magnitude of u times the magnitude of v times cosine of the angle theta between them. All divided by the magnitude of v squared, because now I have two of them. That's squared because of that extra one. And then times vector v on the outside. Okay, but finally, what do I know about, what color should I use? Maybe this color. Let's use yellow. All of this in the numerator here is a dot product. And we saw that from the above, right? So now in the numerator, what I have is simply u dot v, divided by the magnitude of vector v squared times vector v. Okay, so that is, i.e., we have a new way to evaluate the projection of vector u onto vector v, and that is u dot v divided by, really, v dot v, because that's what the magnitude squared is, all times vector v. Okay. Let's do an example or two. So for example, how much room do I have? I guess I'll start here. So for example, find the projection of vector u onto vector v for the following. Okay, so number one, say we have that vector u is 3, 3 root 3, and vector v pardon me, is negative 1, 3. Okay, so according to the above, I have that the projection of vector u onto vector v is going to be u dot v over v dot v, or the magnitude squared. Either way, I kind of like v dot v, all times vector v. Okay, so what does this mean? So what do we have? We have, notice u is only here once. Everything else is v. So I have 3 root 3 dot negative 1 root 3 all over negative 1 root 3 dot negative 1 root 3. Let me put the dot there. Times the vector negative 1 root 3. Okay. So what do we have in the numerator here? We have 3 times negative 1 plus 3 root 3 times the square root of 3, all divided by negative 1 squared plus the square root of 3 squared, all times the vector negative 1 times the square root of 3. Okay, so what does this give us? We have a negative 3 plus 9, right? Because the square roots go away. 3 times 3 is 9. So we have negative 3 plus 9, all divided by 1 plus 3, which looks to be 4, all times the vector negative 1 root 3. So that gives us 6 over 4 times the vector negative 1 root 3. But 6 over 4 reduces to 3 over 2. So let's show that. 3 over 2. So now let's distribute that 3 halves inside, and we get the vector negative 3 halves, comma 3 root 3 over 2. There we are. That is the projection as a vector of u onto v. Okay. Let's see. Do we have another one? Why not? Okay. So number 2 for good measure. So let's say we have u is going to be 2 comma 2. Let's have v is going to be, let's do 3 comma 3 root 3. Okay, so it should be evident before we even begin. Let me note this. The angle phi corresponding to u is pi over 4, 45 degrees, right? 2 comma 2, it's along the main diagonal. This, if I divide by 6, so the angle C, or psi, corresponding to V, will be at pi over 3. Now, if you can't see that, go ahead and evaluate inverse tangent of y over x to show that. But what I'm trying to say here is there's only 15 degrees between these two. So what this means is that the theta is only 15 degrees, which is pi over 12 equals to 15 degrees. And remember, we did cosine of 15 degrees and all of that ages ago. I believe it was the square root of 2 plus the square root of 6 all over 4. But that doesn't matter. We'll get to that. Maybe not. But just to note. So let's get back to what we're asked for, which is a projection of vector u onto vector v. So that's, of course, going to be the dot product of u and v. U dot v divided by the dot product of v and v times vector v. Okay, so what do we have here? So we have a vector u at 45 degrees, or pi over 4, is 2 comma 2. We're going to take the dot product of that guy with v, which is 3 comma 3 root 3. We're going to divide that all by 3 comma 3 root 3 dot 3 comma 3 root 3. And then we're going to multiply it by vector v, which is 3 comma 3 root 3. Okay, so what do we have? So in the numerator, we will have 2 times 3 plus 2 times 3 root 3, all divided by, in the denominator, we will have 3 squared plus 3 squared times 3. And this is all times 3 comma 3 root 3. Okay, so what do I have? I have, I could probably reduce this, but that's okay. Do you agree I have a 3 coming to everything? Why don't I just get rid of that? Let's reduce in hot pink. Okay, so I have a 3. So what am I left with in the numerator? I'll be left with a 2 plus 2 times the square root of 3 divided by 3 plus 9 to So 3 plus 9 is 12. That's going to be 3, comma 3 root 3. We're going to multiply that by 3, comma 3 root 3. Okay, well, once again, we can reduce because 2 goes into 12 6 times. So we're going to end up with 1 plus root 3 all over 6. I guess I'll just keep it in pink. And this is times 3, comma 3 root 3. Hopefully I did this right. Okay, so I can push the 6 in, and that'll give us something on the unit circle, right? So let's just push the 6 inside. So we'll have quantity 1 plus the square root of 3 on the outside, and I'll just push the inside in. And this will be 1/2, comma root 3 over 2. Okay, so what angle is 1/2, comma root 3 over 2? Well, it's still at 60 degrees, right? Because that's the angle psi at which v was. And remember, we're projecting u onto v and then creating that vector. Okay, so hopefully this makes sense. That's it for section 7.4.